Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss on the topic difference equation. Here the question is, solve the non-homogeneous linear difference equation. Del of yx plus del square y suffix x is equal to sin x. First, we simplify this equation. So let we have the equation del y suffix x plus del square y suffix x is equal to sin x. Here, instead of del, we can write e minus 1. Okay. Otherwise, we can operate the property. We know the del of yx by definition is x plus 1 minus yx plus del square yx means what? Y suffix x plus 2 minus 2 times y suffix x plus 1 plus yx is equal to sin x. Okay. So here y suffix x cancel. The remaining term is y suffix x plus 2. Here minus 2 time and here 1. That is minus 1 time x plus 1 is equal to sin x. Okay. So this is the required difference equation. And the order, suppose this is equation 1. If we identify the order of this equation is largest subscript minus smallest subscript, x plus 2 minus x plus 1, x cancel, 2 minus 1 is 1. The order of difference equation is 1. Okay, let us find its solution. As I told you, in a differential equation, the solution set is complementary plus particular. Right now, here for complementary, we use word general solution. And for particular integral, we use particular solution. Okay, so first we find out the general solution here, that is the complementary. For that, it requires the auxiliary equation. We make the substitution y suffix x is equal to m raised to x, substitute here, and then auxiliary equation is here m square minus m is equal to 0. That is m is common, m into in bracket m minus 1 equal to 0. Here m is equal to 0 or m is equal to 1. M is equal to 0 or m is equal to 1. This is not possible. Okay. Otherwise, the solution become trivial. Nothing to prove here. So we consider m is equal to 1 because the order is 1. There it has a only one root. Okay, and one constant. Then general solution y suffix x is equal to c1 m1 m raised to x, that is c1 1 raised to x, that is simply c1. Okay, say equation number 2. Let us find the particular solution. Okay, now for particular solution, we consider this auxiliary equation m minus 1. So instead of m, we write the e minus 1, operate on the right hand side. The right hand side is circular function. So we don't have any shortcut formula for the sine function. So here the sine function, it can be written in a Euler formula, imaginary part of the Euler. We know that e raised to I theta is equal to cos theta plus I time sine theta. Okay, the imaginary part of e raised to I theta is sine theta. The real part is cos theta. So here the imaginary, we require the imaginary part. The particular solution, it can be written as imaginary part. I am writing shortcut, imaginary part of e raised to I x. Theta is x. Okay. Now it can be written as imaginary part 1 upon e minus 1. So it can be written as e raised to I raised to x. So we have the property is 1 upon phi of e operate on the a raised to x. Then it can be written as put e equal to a phi of a raised to x, and the provided after putting e is equal to a, phi of a must be non-zero. Here instead of e we put the a is e raised to I, that is imaginary part 1 upon e raised to I minus 1 into e raised to ix. Okay. Now in denominator here e raised to I is present. It means the imaginary number present in denominator. So we remove this. We multiply and divide imaginary part 1 upon e raised to I minus e raised to I minus 1, multiply and divide e raised to minus 1 minus I. Here minus 1 e raised to minus I minus 1, as like multiply and divide its conjugate, okay, into e raised to I x. Now imaginary part, now simplify, e raised to I is multiplied here, e raised to I and e raised to minus I, base is same, addition of power. Now I am simplified the step here, e raised to I, e raised to minus I, e raised to 0, 1. So here 1. E raised to I is multiplied to the minus 1. Okay, now minus 1 is multiplied here, minus e raised to minus I. Minus 1 into minus 1 plus 1. Okay, now in numerator, e raised to ix is multiplied here, e raised to ix. So here I is common, in bracket x minus 1 is remaining, minus e raised to ix. Okay, now here it can be also written as e raised to I x minus 1 e raised to ix divided by 1 plus 1 2. Here minus sign is common, e raised to I plus e raised to minus I. Okay, and we know that Euler formula, e raised to I theta is cos theta plus I times sin theta, and e raised to minus I theta is cos theta minus I times sin theta. If we take its addition, then e raised to I theta plus e raised to minus I theta is equal to imaginary part cancel 2 times cos of theta. Now here this is e raised to I theta and e raised to minus I theta. So it can be written as, okay. So here the denominator is 2 times cos, means denominator become a real. Now we can write the only imaginary part of the numerator. The imaginary part of this e raised to I theta. So imaginary part of the I theta is sin theta. So here sin x minus 1, and here simply sin x divided by 2, and e raised to I theta plus e raised to minus I theta is 2 times cos of theta. Theta is 1 here. Okay. So which is required particular solution. Then complete solution, y suffix x is equal to general solution plus particular solution, that is C1 plus general is C1 sine of x minus 1 minus sine x divided by 2 is common, 1 plus cos of 1. So which is required solution of the given non-homogeneous linear difference equation. Okay, thank you. Thanks for the watching.